welcome back. Let's start talking about how to calculate statistics on data now that we have a container, our list collection, to store the data in. So our sample data that we'll look at here for quite a while in this chapter is a number of earthquakes per day for 1 week. So we have this data held in a Python list. So note that we've got the square brackets that make that a list, comma separated values, and each one is an integer. And so allegedly these are the number of earthquakes that were detectable on seismographs on a particular day worldwide. So these are just numbers, and then we can start to do some statistics on them to start to understand something about earthquakes and the frequency of earthquakes. Now about that data, usually to do meaningful statistics we'll need much more data than that. And so later on, we'll learn more techniques in Python for reading large amounts of data from an external source, like a file on your computer or some source on the internet, etc. But for now, we'll just use a small enough sample of data that we could just enter the values directly into our program. Okay? So we're just going to have to live with the fact that this is sort of a toy, and we'll look at more voluminous larger amounts of data as we go through the course. So the first statistic that we'll talk about is dispersion. And dispersion measures how spread out the data values are. The maximum value minus the minimum value in this case. We'll look at another measure of dispersion later on. And so if we look at session 4.8, listing 4.1 and session 4.9, we can use the built-in max and min functions to get that range. All right, so let's look at that. Here's using the min and max functions. So I'm going to define my earthquakes list, and then if I call the max function on earthquakes, it gives me the largest value in that list. Likewise, you would expect that if I call the min function on that list, it gives me the smallest value. If I do max earthquakes minus min earthquakes, then I get 18. And so that would be my dispersion. It's also interesting to note that this max and min work on strings because strings are collections. So the max in house is U, so alphabetically U is the largest or the latest letter in the alphabet, and min of house is E because E is the alphabetically first element. So listing 4.1, this uses the max and the min functions to create a function called getRange, which will just give us the range of a particular list. So I'll define that function, and then we can use it here. GetRange of 2, 5 will give me a value of 3. And again, here's a reminder of what the earthquakes data looks like. If I do getRange on that, I get my 18. A second statistic that we can look at is called our central tendency. And our central tendency is a measure that estimates what the typical value of a collection is. So there are 3 kinds that we'll talk about: the mean, the median, and the mode. The mean of a collection, that is the average, is the sum of the elements in that collection divided by the number of elements. So we've got listing 4.4, session 4.10, that show us a hand-built mean function, and also how we might use a built-in statistics.mean function. Okay, so let's look at those. Here is our mean, listing 4.4. Our function for this takes a list as its parameter. We're going to use some existing functions. So sum is a function that already exists in Python, and it sums the contents of a collection. So I sum those up, divide it by the number of elements in the collection, and return that value back. And now I can do the mean on the earthquakes data. It tells me that it's 36.0. And then since Python is used very heavily in things like data analytics, There are lots of modules out there that are already built that do all kinds of statistics for us. So in particular, the statistics module, if we import that, then we can do statistics.mean on the list, and we end up with 36. Okay, same value, different data type. It's returned the mean as an integer rather than a float, but still same value. So that is something that you'll see us do here as we progress. We're going to be building things in Python that already exist. And so it's not really intended to be sort of a torture thing where we're trying to make you do more work, but rather we're trying to learn how to program. And so when we take these problems and try to write our own solutions, then we learn how to program better. And then if later we want to use the built-in versions, we certainly can. All right, our next up video will be talking about the median.